you ever get that sign-in page and it shows your password? See if there's a place.
My password for what? Oh, I think Mom's calling. It's probably. Yeah, hi. I'm back on. Oh, good. Okay, I'll be over for the second class then. It'll probably be 10 o'clock. What is it, 9? No, 11 o'clock. I'll be back over about 11 o'clock. Okay, thanks for the call. So power is back on at the other location, which then I'll go back my next class back up. It's only 5 minutes away. So you're going to hear now they sold the property behind here, the big acreage, and so they're cutting trees down. So it'll be noisy. I'm looking for Jan. No, there she is. Yeah, since I had Taylor's probably right if the power completely went out and I just unplugged, it may have stayed. But because I was restarting my computer with the power, then it forced me to have to end the Zoom session. So next time I'll just try, hey, let's just unplug the power and push the power button down and see what happens. All right, in the meantime, I did just test my document camera and it worked. A reminder of 2 days ago, we did solving equations. And you got some little equations, not too challenging, others harder. You got distributed property, and then you got a few peculiar problems where there was a no solution or infinitely many. That's when the variables disappeared, and then you're left with either a true statement or a false statement. And then a few fractions, of course, that freaks people out. So go see Jan to be unfreaked. I said to the other class last night, same 150 class, at the college skills, you're going to try it, go to college skills, the tutorial, ask for Gordon Schmitzu. Schmitzu. I don't know if that's Japanese or probably, I'll say Japanese. I've never asked him what his nationality is. Anyway, last name, just say Schmitzu. Gordon, I think there's only one Gordon. Really great guy. He loves working with my classes, and Jan knows him well, and probably even had him did you have him as an instructor, Jan?
No, he was something at Santa Rosa High when I was there. He was, but not math. So I just knew him from being at the same school when he was teaching.
Okay. So that's another resource. You can't hook up with Jan with her times, then Gordon Schmitzu. Ask for him, and he knows my class. And I think they actually I've sent them over readers like this. So they should all have readers to be able to use, I think. But I'll email him the day I ask him that question. Matter of fact, I might even ask him, this is a good idea. Jan, could you send me a text message about this? That I would ask him to join our Zoom class here on both of them, just to introduce himself. I think that's a good idea. And then he can describe how the Doyle works and what to do to access him. So I think that's a good idea. So text me that information.
Yeah, and his last name is S-H-I-M-I-Z-U. I'll put it in the chat so that you guys.
All right. Good. So then that wraps up solving equations, and then 2.5, we're going to have some small word problems. Now, that's already like fractions, freaking you out, word problems. these are not, I held back the biggies. 2.6 and 2.7 sections are the biggies. So those type of word problems, I put them at the back end of our course in a different section. They come up again. So this is the only little section that will do how to set up the applications and how to come up with the result, make sure the results make sense. Now, this here, if we were face to face, I'd be looking for this every single time on the exam. Of course, the exams now are multiple choice, and you just pick the right answer. So however we get your answer on the test, sometimes it's guess and check. I mean, if you look at the multiple choice answers and you say, let's see, there's 2 that are negative. Okay, how can you have negative money? Or how can you have negative pieces of wood? That doesn't make any sense. Temperature to be negative is okay to make sense. Let's see, profit and loss. I mean, to have in a business, to have a loss negatives make sense. But like speed, how can you have negative speed? You can't go backwards. So that on a test, you might look and say, well, throw those answers away, like here. You know, if I look down here at the bottom, you know, let's see, find the discount. The discount, how can a discount be negative? That doesn't, you subtract the discount off, but to find the percent, negative percents doesn't make any sense. Find the new price. Oh, it's negative $50 for a shirt. So some problems, word problems, if you look at multiple choice, the negatives don't make sense. And like, find the new price of a, let's see, what is this, a car? Well, okay, it might make sense because it's money to have decimals. Because it's cents, it's pennies. That one might make sense. I'm thinking, hey, fractions or decimals, do they make sense with certain problems? Let's see, I'm just looking at this before I show you my setup. Pieces of lumber, find the lengths. Well, it'll make sense to have fractional length. That'll be okay, but to have negative answers for lumber, that doesn't make sense.
Hey, Jeff.
This one here talks about angle.
Gordon can join us right now if you want him to meet everybody. It's up to you.
Ask him if it, because of the sketchiness of the internet and me, and we've got a group quiz or a little quiz, ask him if it would work for tomorrow night, 6 o'clock,
and then
Monday of next week.
Okay.
Yeah, for this class. Let's ask him that.
Okay, got it.
Thank you.
Yeah.
And this is angles. You don't know this, but negative angles work. You don't know that. For you guys, it wouldn't make sense for it to have negative angles, but in real life, if you take a trade class, negative angles. So sometimes negative answers are okay, and sometimes it doesn't. All this says is, I'm trying to give you an idea of how to proceed with the algebra if you need it. If you can guess the answer, good for you. Here, I'm going to show you something. The number 126 is 35% of what number? I'm not showing you the algebra on this. I'm just trying to think, see, common sense or any kind of sense at all. Gosh, 126, 35%. You have to think about what it's asking. Okay, there must be some number, some number where you take 35% of it and it gives you, it's like working back, and it gives you, that number ought to be bigger than 126. I guess that's all I'm thinking. Now, you might be able to calculate and kind of guess and check, guess and check, guess and check, and stumble on it. That seems to be frustrating. So what I'm going to show you is maybe some techniques to work with. So figuring out what your variable represents, that's one thing. When I go over here and say, hey, can you figure out what your variable is? Then why don't you write it down to help you focus on what you're trying to solve for? Can you come up with an equation? And that is the hardest part of this whole thing. Because once you get the equation, this solving should be easy for you guys now that you've done 2.2 and 2.4, because that's really all it's doing is solving the equation. And then when you're done, you look at your answer and it doesn't make sense. So this is the hard part, of course. All right, now, when I look at this first problem, it says right here, what percent? So I might say X or X percent. How about this? X is the variable. This is equal to what percent? Now, I'm a little baby equation on this. You see the word is right here. That's like equal. So from left to right on these two problems here, from left to right, the number, okay, 28.6 equals what percent? Now, if I put the percent sign, it seems like it's in the way. Feels like it's in the way. So I'm going to drop it off for right now. And even right here, just know that I'm supposed to answer this as a percent at the end. That's the idea. So I'm going to drop the percent symbol and the word of. Now, gosh, I'm thinking 2.1 maybe. Remember the symbols, plus, minus, subtract, same thing. Plus, well, here, I'm going to show you. There. See all those right there? You came up with words like product means times. Well, sometimes the word of implies multiplication, and it does in this time. Sometimes the word of.
Do you want us to be able to see your handbook?
Say again?
Do you want us to be able to see your handbook while you're discussing this?
Can you not see my handbook at the time right now, Taylor?
No.
I can see
Jan,
it.
can
Yeah, I can see it.
I can see it too.
so it might be your machine, Taylor. Sorry, this time.
Okay.
I'm not sure.
It's up on my screen.
And if you need to exit and come back, Jan will let you in, Taylor, and see if that helps.
Thank you. Sorry about that.
Yeah, no problem. Glad you asked. So what do you see, Taylor, right now, by the way, if you're still there?
I think she went
Okay,
out.
yeah, that's fine. So the word of implies, like I said, like this, half of 100. You guys know that's 50. Half of 100 is 50. It's the same thing as going half of 100. So like the word of implies multiplication. I'm going to go back over here and I say what percent of, that's like multiplication by, Now, another way of writing this, because it looks a little awkward, what property allows me to put the 52 in front? Anybody want to chime in? What property allows me to switch the X and the 52? There's a title to that property. You guys need to know what that. Right. Very good. Commutative. Don't forget to throw in the multiplication at the end too. Then this feels like a little more familiar. So then at the end you go X equals, and then you take your calculator, which I have one somewhere. No, somebody do it for me. My calculator's in my backpack. Go this number divided by 52 and maybe squiggle like this. Maybe not.
0.55.
Say it again, Jen.
0.55.
Okay, so it's not even squiggle, it's equal. Now, that's not a percent, so I got to change the decimal to a percent. So the answer, excuse me, the answer is 55%. So what this says is if I want to check it, 55% of 52 had better be 28.6. 55% of 22 had better be 26. That's a way of checking it too. Well, half of 52. Okay, what's half of 52? That's 26. And a little bit more gets me, hey, that looks like it makes some sense. So 55% should be the answer. All right, this one here, the number, okay, there's the word is. So the number 126 is 35% of what number? Oh, okay, like that. So X is the number. X equals the number. So what I'll do is I'll divide both sides by 35%. That's the same as taking 126 and divide it by 0.35.
3.6.
But no. Take 126 divided by 0.35. There you go.
360.
Can I get a confirmation by somebody on that?
Yes.
Yes, 360.
Okay, so it looks like that would be the answer. Of course, you box it. How do you check it? If you took 35% of 360, that means take 35%. Oh, you got to change that to a decimal. So 0.35 times 360, does it give you the 126, which it will when you check it. 0.35 times 360, that's should give you backwards 126.
How did you get the 0.35?
So percent, where's the decimal right here? It's right there. Okay, to throw away the percent, you got to move the decimal to the left 2 places. So 0.35. So this decimal, okay, what's the fractional value of this? Anybody want to jump in and say, how do you change this to a fraction? How do you take 0.35 and make it into a fraction? Anybody?
1 over 0.35.
Not quite, but good try, and thanks for chiming in. And
Is it
taking it.
35 over 100?
That is it, Russ. Yeah, so this is place value. All of you hopefully know your place values as well. This is tenths, hundredths, TH. This is 35 over hundreds place. So that's 35 over 100. Percent is always out of 100. So that, to me, it makes sense. 35 over 100 is 35%. So that's the fractional answer, but that's the decimal answer, and that's why I put it over there. Does that make sense? I think it's Robin, right?
Yeah.
North Coast SC to Bonn.
Sorry, let me change
North
that.
Thanks, Robin.
Thank you.
Okay, number 3. So you go to this dealership where they sell automobiles, and they reduce the price of the car by 8%. So there was a price that they start with, and they reduced it by 8%, and they give you a new sales price. So it says right here, if the price of the car before the discount, so here's the original price. So you might say, here's the original price, and then you're going to subtract the discount price, and that gives you the new price. So original price, discounted price, new price. This is all about money price. So the original price is $18,500. Now you're going to subtract off the discounted price. So what you do is you're going to take 8% of, see, you hear me say the word of, that's times 8% of the 18,500. I'll do it over here on the side. Well, I can do it right here. 8% of the 18,500 should give me the new price, which that's what I'm trying to find, like right here.
Is it 17,020?
See, find the new price. So right here, is that what you're saying? Or are you saying the 1720 or 020 is the new price, Russ?
17,020 is the new price.
Okay, so how did you get that, Russ? You're going to have to unmute your microphone again. Sorry.
I multiplied 18,500 times 0.8. It came up with 1480 and then subtracted it from the 18.5.
I'm not sure if you said 0.8 or 0.08, and that was my
0.08.
old ears. Thank you. Okay, that is correct right there. So he's taking, this is the discount. And it says find the discount. So he found the discount right here to be, how much was this, Russ?
1,480.
$400, and at the end, 17,000. Is that what you said?
020.
So then you now know what the price that you're paying for at the dealership. It's $17,020. Okay, next problem. Number 4 is like a meaningless problem. Number 3 was meaningful because everybody, I mean, it makes sense. It's a real life problem. You go to a car dealer and you say, I wonder if they're giving me, really, truly giving me an 8% discount. And hopefully you know how to check the dealer to see if they're doing it right. This is meaningless. It's just about stupid numbers. It's the idea of how to find the stupid number, find the number at the end. So, okay, X equals number. It's algebra here. And then here's the difference. Okay, that would be a subtraction sign. I think everybody knows what doubled means. You're multiplying by 2. And the result is, hopefully you know that's going to be an equal sign. More than probably is an addition, which I'm going to say it is. So here's an idea. You're going to take a subtraction, a difference between two things, okay? Anybody remember the phrase back in 2.1, the phrase that says you take and do a swap? It's, you know, for the subtraction. What phrase you had to swap? You ever remember swap? Anybody remember that? It was a 2-word phrase. I gave you an example, and the textbook also had a couple. So you don't go x minus a -5. You had to go negative, I said -5, that was weird. X minus a -8. You have to do it backwards. -8, subtract x. Subtracted from, you got to be careful of that one. But the one we have is called difference, like right here. You know, find the difference between 8 and double the number. See, that's kind of same idea. We're back over here to this problem. I'm going to find the difference. In this case, it's between a number and 4 is doubled. Oh, okay. Now you have to be careful because sometimes it's the interpretation and how you read it. I'm going to read this over again. If the difference of a number and 4, okay, I'm going to pause, take a breath, is doubled. This is different. If the difference of a number and 4, it's not just the 4 is double, the whole thing is doubled. If the difference of a number and 4 is doubled. Now, I believe I'm right. I was about ready to do it wrong, but I got it right. See, this sometimes it's tricky. The result is 16 more. So more means like I'm going to add 16 to something. Add 16 to the number. Now, is this possible to actually do this, guess and check? It's probably possible. Yeah, and you'll probably stumble on it eventually. 5 minutes later, you're trying all this stuff. You got to find the number, and then what you want to do, take the number and 4, subtract it, double it. I mean, you might be able to guess and check. This is just an algebra concept.
I have a question.
Uh-huh.
Where are we getting the minus sign? If it's 4, the difference between 4 and a number, okay, is subtraction. The difference. Okay, thank you.
Okay, an equation like this is piece of cake, right? This is what you guys are working on the last couple days. Distribute, collect like terms, and solve for x. This is like 2 or 3 steps. Should be a no-brainer for you, but the hard part was setting up the darn equation. So how about this? And then you got 2x subtract 8 equals x plus 16. And then what did I say? Which side of the equal sign did I say that you should put the x's on? Left or right?
Left?
Was that a question?
Oh, no,
You're not
answer.
sure? Or left?
Left.
Agreed. Good.
Didn't you say it wouldn't make much of a difference now, but later it would?
Yeah, I emphasized that. You're right. Good. So you remembered that. So you're right, Russ, as well. But when Robin said left, good for her, because that way, even though she doesn't know why, she's just saying, I'm always going to do it left because Jeff tells me to do it left. Russ is saying there must be a reason, and he's curious about that when we get to the end. Okay, that's good. I'll show it to you why. So subtract x here, subtract x here. X subtract 8 equals what, 16? Add 8, add 8. Must be 24 if I haven't made a careless mistake. Now, if I want to check this and see if it actually works just by the words up here, this is the number. The difference of 24 and 4. The difference, this is 24. Difference of 24 and 4. Gosh, that's 20, isn't it? And it's doubled. Okay, well, what's 20 doubled? 40. Right now I got 40. The result is 16 more than 24. 16 more than 24. 16 more than 24. Are they the same? It is. 40 equals 40. It checks out. So that would be your number right there. Now, if this was face-to-face, which we're kind of face-to-face, right? I mean, we are. If this was in a classroom where I'm grading for partial credit to see about process, then I would require this. Now, I will on the group quiz. That's about the only place that I'm going to look for on the group quiz. You got to give me a sentence if it's a word problem. So what you do over here, you'd say the discount price is 1,480. You'd say the discount price is 1,480. The new price is that. The THE new, you can get it. Sentence. This one here, you'd say the number is 24. Sentence. That's not a sentence. Yeah, you start with words and you end with words. Now that's for the group quiz. The exams, multiple choice, pick the right answer. The little baby quiz today, for instance, just pick the right answer. I don't need process. Your homework, you might want to try practicing putting some sentence in there, but I'm really not going to look at your process. I'm just going to see if you've attempted the problems. That's all. And you'll get your 20 points. Okay, this one here, piece of lumber. Jeff, I don't know what you're talking about. I've never gone to a hardware store. Yeah, I know. Sometimes you get word problems that you don't know what it's all about. So I'm just going to try to focus on the hour. Okay, I said something about a number here, 21 foot. Okay, now what the heck is this? This is a type of wood. So the 2, and that's like a multiplication, or the word by. Yes, if I say 2 by 4, a 2 by 4. You might have heard your uncle, your dad, or your brother, or somebody, hey, I've got a 2 by 4, or a 4 by 8, or a piece of plywood, or something like that. This is pretty standard piece of wood. Contractors might use, would use, I should say. So it has nothing to do with the actual equation, but that one does. Okay, so a 21-foot piece of board is to be cut into 2 pieces. Oh, okay, so here's my board. I'm going to draw a picture. Here's my board. That length right there is 21 feet. So this length is 21. So sometimes drawing pictures help. Yeah, Russ?
Can we use the sign above the 21 as feet, or do you want us to write it out as feet and inches?
Your choice.
Okay.
Your choice. Like little tick mark. That's very common to use in abbreviation. FT, FT for feet, FEET, or foot. Yeah, it doesn't matter, Russ. Thank you. Okay, so going to be cut in 2 pieces. Gosh, are you going to cut it right in half? That's too easy. No, one's longer than the other. See, the longer piece. So let's like cut it right there. That's my cut. Here's the short piece. Here's your short. Here's your long. And together, they're going to give you 21 feet. All right. The long piece is compared with the short piece. The long piece is a foot more. Okay, that's a plus right there. The more means plus. Of course, times is times. Got to know something about the short piece. Yeah, I have to know something about the short piece. So that up here, this long piece is a foot more than 3 times the short piece. A foot plus, adding a foot to triple the long piece. And here comes the equation. Together, you add them together, is going to give you 21. So I'll do it like this. Short plus long equals, I don't know, original or total. Short is x plus long is 3x plus 1 equals 21 feet. And you'll say x equals the short piece. And that's the hard part, is finding the equation just like I did right there. And gosh, this one's easy at this stage, but the hard part was all of this for you guys, I think. Because right now you just collect like terms. let's see, these two are like terms, so that would be 4x, and then plus 1 is equal to 21. Subtract 1 from both sides, you get 4x is equal to 20. And then, gosh, forget the algebra, 4 times 5 is 20. I mean, I'm looking at that. You guys know that. I mean, at some stage, you can skip some steps if it's obvious, like 5. Hey, x has got to be 5. And then I might look and see what they're asking for. Oh, they want to know how long both pieces are. Oh, okay. So then you'd say something like the short piece is 5 feet and long piece is, okay, how do you figure out the long piece? Russ, you're trying to say it, but there you
Do you
go.
subtract 5 from the total length?
So there's an idea. Here's total length, and why don't you subtract 5 from that to give you 16? That's leftover. Okay, here's another idea. Put the 5 right there. See, that would be 3 times 5 plus 1. Put the 5, that'll get you the same 16.
Is it possible we can try another problem similar to this?
Do you have one in particular?
Like this one, but I don't know, just by, because this one's complicated and like,
You have your textbook on you?
yeah.
Why don't you pick one out of your textbook?
Okay.
And shoot, I don't have any scratch paper. Okay, I've got an envelope. This is my scratch paper.
In 2.5?
You want
Yeah,
me
2.5.
Laura, I found one. You want me to put my,
Oh, sure.
yeah,
That'd
let's,
be great.
Could be any of these kinds of problems. Maybe she's just thinking problems in general,
how about,
rather than just another wood problem.
okay, here's a rope problem. You want to do this one, Jeff? On
A
page
what problem?
ROPE on page 117, number 10.
Sure, that's a good one. Now, they're giving you information and how to set it up. I might not. I'll cover that up. I might not. So it's the same concept here. A piece of rope is used, and it's cut into 3 pieces. So what I would do is, picture-wise, pretend my pin is a rope. I would cut it in 3 pieces. So there must be, they're not all the same length, I'm sure. You'd have a short, maybe a medium one, and a long one, maybe. And then here it says 46 feet. So this pin is 46 feet. That pin is 46 feet total. Okay, so there's a first piece, second piece, third piece. Okay, so one's short, one's medium, one's long. The second piece, probably maybe the medium, is 3 times as long as the first piece. First piece is probably the short one, probably, because 3 times as long means it's longer. So I'd probably do what they're doing here. See, the short piece is X. The second piece is 3 times X, 3 times as long. And the third piece, probably the longest, is 2 more than 7 times the length. We're back to the first piece. So X must be equal to the first piece. So here's the first piece. Next one is 3 times the first piece. And this one here is 2 feet more They did 2 plus rather than plus 2. It doesn't matter. Then 7 times that piece right there. And then all together, so you're going to add all of these up, and it's going to give you 46. So I'm not sure who asked that question again.
Laurel, I think. I
Laurel?
think so. Yeah.
So
Yes.
see how that works, Laurel, then?
Yeah.
All together, you're going to go this plus that equals 46.
Okay, so add them all up.
Mm-hmm.
Okay, that makes sense. Thank
So
you.
here's another one over here, number 9, which is before that. So 3 pieces again, 3 pieces. Okay, the whole thing is 25. Okay, cut into 3 pieces. Okay, the second piece is twice as long as the first. This extra piece is 1 inch more than 5 times the length of the first. So if 9 feels just like 10. The board that I did was just 2 pieces instead of 3.
Hey Jeff, I just have one question for 5. Where did you get the 16?
Oh, here?
Yeah.
Okay, so Russ said it's 16 because 21 was the length of the whole board.
Okay.
So you cut off this amount because that's what you found was 5. This was 5 feet right here. This
Okay.
is 5 feet. This is the 5. And he says, if that's 5 right here, this is the leftover. So he just subtracted 5 from 21. This has to be 16 right here. That's how
Okay.
he did it. The other
Okay.
way, Rob, would be to go 3 and put the 5 in right there and add 1. This is the other way to do it.
Okay, thank you so much.
That will give you 16 as well. Okay, flip the page. I got something about angles in, let's see. Somewhere, everybody may have, at some time in high school or middle school, had a geometry type class, and you would have heard the phrase complementary. I'll bet 99% of you have. It depends on which school you went to and maybe which country you came from or whatever. You might not have. But the vast majority of us have always heard complementary, just might have forgotten what it means. The other word in geometry, and the book defines this. If you look in your textbook, they go through a definition of both of these as well. So you can find it in your textbook, author. So supplementary and complementary. Complementary means that you have 2 angles and they add up to 90 degrees. See, in 90 degrees, I think all of you, hopefully, maybe 99% of you, know that that little symbol means a right angle. That's another way of saying it. It's a right angle, 90 degrees. So this is 90 degrees right here. So if you bust it up any way you want, like here, these 2 here have to add up to 90 degrees to be complementary. Then supplementary would be similar, except it's 180 degrees. Now 180 degrees goes all the way across on a straight line. That doesn't look too straight, but that's supposed to be a straight line. This is 180 degrees. So supplementary says if you took 2 angles, this one and that one, they always have to add up to 180 degrees. That's complementary. So this one, it's ready for you. It's all set up. You just add these 2 angles together and it's supposed to give you 90. And you collect like terms. And you add 3 to both sides. And you divide both sides by 3. And you get the number 31. That's the algebra. And you say, well, 31 means something. And you go back and look at the picture. Oh, 30, that's that angle right there. So you'd say the two angles, or the angles, are what, 31 degrees. And now there's 2 different ways of coming up with the second angle. So Russ, for instance, gave you guys an idea that if you have 31 degrees for some of it, the leftover is where the difference is between 31 and 90. Oh, 90 degrees. 30, the difference here, 90 is all of it. This is 31. This is the leftover. Or you could just go to this and say, well, 2 times the 31, subtract 3, should give me the leftover. This is what, 62, subtract 3, 59. And if you add these 2 together, it should give you 90. It's supposed to give you 90, which it does. Okay, it gives you a sample of the problems that you'll see others that on the homework, and I'm sure after today you'll be seeing. Jan, I'm thinking they're going to be coming and seeing you this weekend or Monday morning. The word problems alone will be challenging, so
Sure.
anticipate more than normal, I think. Okay, so the other section that I want to do, I'm not going to do them all because you'll get the idea. These are formulas, and your job on some of the formulas is to plug things in and work them out, plug them in, work them out, or solve for one of the variables. Let's say one here, which is D equals RT. Let's say a different problem, different instructions would be find, that's a weird word, not even a word. Find T if D equals 40 and R equals, I don't know, 2. And by the way, this is called the distance formula. So distance equals rate times time. So that's like the speed. R is the speed and T is like time. Oh, okay. It says, well, find how long it'll take to go 40, I don't know, miles if you're going 2 miles per hour. Like how many hours is it going to take you if you only go 2 miles per hour? So you would go and do this literally. So you go 40 equals, and then R is 2 and times T. And then you, of course, solve for this. And you say, well, it's got to be 20. T has to be 20. So there'll be some problems that are like that. The ones I've got set up for you are a little different. And you'll be asked to do some of these problems too. They're different in that you don't plug anything in, you solve for the variable all by itself. When it says solve for R here, see right here, solve for R. That means you want to get R by itself, get rid of the letter T. Okay, there's a times right here. How do you get rid of the T? Anybody, how do you get rid of the T?
Do you divide by t?
You do. You do. So get rid of multiplication by division. So all you have left is D over T equals R, and that's all you're asked to do. Get the R by itself. And I put the R on the right-hand side. It really doesn't matter. The variable on the left-hand side comes into play if you only have one variable. That's when it's important to keep it on the left-hand side. This one here, gosh, I want to get the C by itself. How about move these two over to that side? How would you move the A and the B over here? Anybody?
Is it
You
A
don't
minus B?
Say it one more time.
Sorry, is it A minus B? You subtract it?
So you subtract, and one more time, Matt, subtract what?
A minus B from the right side and bring it over to the left?
Yeah, so the way you're saying it, it's just my mathematical brain is not quite right. So how about this? I'll paraphrase it for you. So you're going to subtract A and you'll subtract B. That's what you meant to say, but it's just the way you said it. I'm going to subtract both A and B from both sides. That's how I'll move it. So that's true. So you're going to go subtract A and subtract B, subtract A, subtract B. All right, got C by itself. Are these like terms, Matt? These three variables, are they like terms, Matt?
Oh, sorry, I was muted. No?
Correct. So you say, well, how does Jeff want me to write it? Alphabetically? Okay, doesn't matter. There, I accomplished the goal. The goal is just to get the letter by itself. That's it. Let's do 3. This will be the last one on this page. Let's do 3, and then I'll look at the other page and see what that's about. Okay, 3, I want to get W by itself. Okay, so this is the one I want to get by itself. So I have some stuff to move. Okay, anybody want to make a suggestion? What do I want to move first? I want to get the W all by itself on the right side. What do I want to move first? Any ideas?
The 2? The 2
Yeah,
in
see,
front of the W?
you want me to move the 2 in front of the W? Okay, how do you undo the 2 from the W? I think that was Robin.
-2 on both sides.
Okay, what's the operation 2 has on W? Is there an addition between the 2 and the W? How do you undo multiplication?
A fraction?
Okay, so how would, go ahead.
Do you do division?
You do. So if you're going to move this 2 first, then you would divide. Here's the thing. You have to divide both entire sides by 2. Everybody has to be divided by 2, both sides. So I'd have to divide the entire side. That means you'd have to divide this by 2 as well, and this by 2. So it's not a problem. It's not wrong. If I divide by 2 here, you have to remember to divide both sides, everything by 2. And then you got a P over 2 here, and you got an L still left and a W still left. So that works, Robin. And then what's the next thing, Robin, you would do?
You want to get rid of L.
Yes.
So
Idea?
Yeah, is it negative L on both sides?
Yeah, you subtract L from both sides. Good. Subtract, subtract. Okay, the nice thing about this, it's gone. So then you're left with W. And then these two things, Robin, are not like terms, so you just write them separately like this. And that's an answer. Now, somebody else out there is asking the question. Somebody else is asking the question, but you're not asking it. You're thinking in your mind, gosh, Jeff, could I have moved the 2L over first? Yes. Yes, you could have. Could you have moved? Here's the same problem. Could that be moved over first? Yeah, you subtract 2L from both sides. 2L both sides.
That's 2W, Jeff.
I understand what you're saying. This is a W here. Thank you. And then you get rid of the dividing 2 to both sides. You got to divide 2 into both sides like this. And if I did that, the right-hand side is plain old W. Now, the left-hand side is a P minus 2L over 2, but that's the same as P over 2 minus 2L over 2. Now, P over 2, look down here, there's your P over 2. And if you did 2L over 2, the 2's go away and you're right back to where you started from. So you get the same answer. You get the same answer. All right, the rest of these are just formulas. They're very similar. Some of them are familiar to you. You know, like the one, number 5, it's pi r squared. Area of circle. Over here, area of a triangle, volume, y equals mx plus b, and so on. So actually, I'm not going to finish this up. You can maybe, Jan, you might want to consider, if they come into your room after the quiz, doing the rest of these or some of this. Maybe that's just an idea.
Definitely.
Okay, so I'm going to stop my video, stop my share, I should say. And I'm going to show you what we're going to do next. So give me a second to make sure I'm up and at them. No, I'm not. Yeah, my internet speed over here is a little slower than, oops. Okay, can you see this, Jan?
Yes.
Can you see the, okay.
Yeah.
Make sure this is you guys.
I think it's the gray one, Jeff. I think it's the other one.
Yeah, I want to see, it's supposed to be Tuesday, Thursday. Oh, yeah. I always get these things mixed up.
Yeah, me too.
Yeah. All right, now I'm going to go in as a student. I just published it. I just turned it on. I'm going to go in as a student. Hello, hello. Oh, it's still spinning. Yeah, slow internet. Hello, where am I? Okay, maybe it's under settings. Yeah, student view. I saw it somewhere. Where are you? Oh, down here. So I'm going to show you, when you bring up yours, you can do this along with me right now. Get into your Canvas. Under assignments, if you click on that, you're going to look for daily quiz number 1. There it is down here. Little airplane means I published it. And then what you can do is say, take the quiz. Okay, let's see what happens here. So then I'm going to put you in with another person, like a pair or three of you, and you guys get to look at this together. You can answer it differently. If you don't agree on number one, like, which number does this belong to? And if you say whole and the other person says natural, you can disagree, up to you, or you can agree. But then you need to take it right now. Don't leave class without having done your daily quiz. Once you finish your quiz, it'll show you what you got right, what you got wrong. And then you can jump out. I'll be around for a little bit, and then you can go to see Jan as well for the remainder of the time. Make sense, you guys? Yes? No? Maybe? Yes? You see that? Anybody not see that in your Canvas? Because it should be there. Okay, nobody's answering. That's fine. That means you all see it. Good, good, good. Okay, if you have never done breakout rooms, what I'm going to do is set up these little rooms, and you will be with one. Maybe I'll do three, 2 to 3 today. Usually in little baby quizzes, I just put you with one other person. But today I'm going to put you in with an extra. So I think most of you will have 3, might be 1 or 2. Oh, I got to see Jan is not supposed to be in a room. Let's see if I can do this. Oh yeah, Jan's in her room. Okay, sorry, Jan. I'm gonna move you out. Okay, whoever's in your room. Got it. Gosh darn it! Come on.
Could have given them all the answers.
Okay. Oh, are you serious? Okay, so I'm moving this person to number 5. Okay, I think I'm good. So I'm going to open the breakout rooms. When you see it, you just join your breakout room and then go hang out with other people, and we'll see you either Monday, or you can come back out and talk to me later.
And the link is in the chat for the other room.
Do you see it, Sandy? Are you okay? You don't see the invite, the breakout room? Your microphone's muted. Can you unmute your microphone? You know how to do that? She doesn't know. So the bottom left corner, can we unmute her?
I'm trying to. It's only telling me that I can ask to unmute.
That's what I did too. So Sandy, the bottom left, I think, corner of your screen has a little microphone. And if you click it once, I think your microphone with the red will turn away. You don't see it.
What about you, Ryan? Are you having?
Yeah, I didn't get a room. Like my internet dumped me out for a minute, so I think I just fell between the cracks there.
Is he in? Okay, Ryan's in. Well, let's see if I can put you in a room here.
You can put him in 8 because I was supposed to go in 8.
No, you don't have anybody with you, so I got to put him with somebody else here. Let's see. How do I do that? Breakout rooms. Let's see. Can I add another breakout room? I've never done that before.
Could Ryan and Sandy just
I can
stay?
put him in 9. I can put him in 9. Let's see. How do I move if it's got dropped? Breakout rooms, Ryan. Okay, I'm looking under his name, see if I can slide him into a breakout room now. Ask to mute more. Oh, put in the waiting room. No, I don't want to put you in the waiting. I'm going to try putting you in the waiting room. Might be a breakout room. Hold on a second, Ryan. Shoot. Okay, fine. That didn't do it. I put him in the waiting room. That didn't do it.
Maybe.
So Ryan, okay, how about this? You and Sarah, you and Sandy are together right now in this room. And then Sandy, you can't, oh, look at this. Sandy might be.
Figured it out on my phone, so trying to.
So you've got background feed. You might have to turn your mute off on your computer.
Yeah, you're gonna have to kill one of them because it's crazy feedback.
Right.
Yeah, on your computer, there's I don't know which kind of computer you have. You usually there's a microphone off.
Okay, I'm going to go to the
So,
other
Ryan-
room, Jeff.
Okay, Jan. So Ryan, you could start working on it yourself. I'm okay with that. You don't have to wait for Sandy. You can just start working on it right now, and if you have any questions, you can ask me. Okay. And in the meantime, Sandy, you might chat.
I think I figured it out. I think I
There
got
you go.
There you go.
Good. Okay, you guys talk, and I'm just going to step away and get a cup of coffee. Okay.
Okay. Thank
Cool,
you.
cool.
Sorry, guys. This is craziness.
No worries.
So
All right.
I don't really know what to do on my side. Can you still hear me, Ryan?
Yeah, I can. Yeah.
Okay.
So,
you go.
just like minimize this so you can still see me, and then jump into your canvas.
Okay, that was the hard part I was just having when I tried
Yeah.
to jump into my canvas. So I think what I'm going to do is I'm going to multitask, stay on the computer, and do canvas on my phone.
There you go.
Yeah. Is that
Whatever
okay?
works.
That works?
Just let's just mute one of them, because when you got them, it's like a Jimi Hendrix concert.
I shouldn't have you on my. I shouldn't have you because I'm just going on a canvas. I'm not going on a Zoom, which
Oh,
just.
okay. Oh, I see what you're saying.
No, I'm still trying to
I'm with
figure
you.
it out. You know, it's super crazy. It's really nuts. Okay, so I'm gonna go. Where did he say? Where are we supposed to be taking this quiz at? Is it
Yeah.
gonna be an announcement?
So if you go to assignments,
Assignments. Okay, I'm on assignments. Thank you
and
so much.
then sure, yeah, no worries, no worries. And then I found it. Let's see. Let me
Okay,
go
group
back.
quiz, right?
Yeah,
So,
daily quiz. Daily
group
quiz
quiz.
1.
So I'm gonna go to group quiz number
Well,
1.
Yeah, daily quiz.
Oh no, that's not it. That's says it
Da-
says it's locked.
Yeah, daily quiz number
Oh,
1.
daily quiz.
Yeah.
Okay, and then I'm gonna hit take quiz. Did you already
Yep.
do that?
I'm doing it right now.
You did? Okay, I'm gonna put take the quiz. Okay, so
All right.
which number classification does the number 0.5 belong to? Okay, which number classification? Which number classification does the number 0?
That's a rational number.
It's a rational number?
That's what I have, yeah.
Okay.
Rational numbers are negative, positive.
Oh,
and
wait,
then-
wait, I'm gonna write this down.
Sure, yeah, yeah.
I'm really new to all this. Okay.
Yeah, no worries. So rational numbers,
Uh-huh.
they are negative, positive. That includes 0. They're decimals and fractions. All of those are rational.
Oh, you know what? Is that I don't have my book.
Yeah,
It-
that's where I got it from.
That's how we got that from, huh?
That's a thing, yeah.
That's probably because I got, yeah, I think that's I was just writing down what he was saying. So is that going to be from your guys' Math 150, Ryan?
Yeah.
Or is it from, there's 2 books that I didn't get them yet.
Yeah, so the reader.
The reader.
So so the actual textbook is beginning algebra,
Yeah.
the 7th edition. That's where I got that from.
Okay, that's probably going to be a tremendous help when I finally have that book. Okay.
Yeah, I got mine from Amazon for like $25. I rented it.
Okay, well, I'm just still waiting on the JC. It's just been kind of nuts.
Mhm.
But if you have yours, I do appreciate you
Yeah, for
that
sure.
little bit of knowledge there. So thank you. Okay, so question 2, which number?
Yeah, so square roots and pi are both irrational.
Okay, I'm writing down what you're saying. You're kind of like a tutor at the same time.
Right on.
Square root and pi
Yes.
are what?
Square root and pi are classified as irrational.
Classified Okay, so where are we at here?
All
So
right.
it would be rational again,
I would have it as
right?
I would have it as none of the above,
None of the above. Okay.
because irrational is
Because
not.
it's irrational, not
Yeah,
rational.
yeah.
Thank you.
That
That's
would be
kind
my. I mean, hope we'll see when it gets graded real quick.
it's
But
okay. This is all learning experience, so I'm not.
cool.
This is all super. Yeah, it's all really new. So actually, it's really nice to talk along with somebody.
Awesome.
Yeah. Thank you. Okay. Now we're on number 3. Did you already answer all these?
I did not.
Okay.
I'm doing them right now.
Okay. Which property is being demonstrated?
Other Alexa thing.
Commutative.
Oh, that's
Which property is being demonstrated?
yeah. I think that's commutative.
Commutative.
Yeah, I think so.
Yeah.
For addition. Yeah, for
For
addition.
addition?
Yeah.
Yeah. Okay.
Wait a minute.
You want to reread it?
No, that's associative. That's associative.
Associated for addition?
I think so. Yeah.
Which property is being
For addition. Yeah, I think that's
Okay, for
associative.
addition. Okay.
Yeah.
Wonderful.
We shall see. Let's all right. Number 4.
That's good. Working through it. Okay, which is okay, number 4.
So Taylor and Mitchell, that's all I got for you. The other 2 are working together. You can go see Jan now if you want to.
I think I have to go back to you, Ryan. Like click on you. Maybe.
Oh,
there we go.
here I am. It's just maybe because I wasn't talking. I just need to look something. I forgot what a coefficient is. Give me one
I
second.
don't know, so I'm still learning that, which I'm learning now as we go along to this.
Yeah, me too. It's been forever since I had to do this stuff. So
It's been 20 years for me.
yeah, me too. Well, yeah, close enough.
Yeah, so long time.
Yeah. Let's see, a coefficient, numerical or place before multiplying.
Coefficient.
Oh, okay.
What is it?
So a coefficient is a numerical or constant quality.
A coefficient is what, Ryan? Would you say that again?
Yeah, let's see. Here, let's do this.
Coefficient for, oh, okay.
I'm going to try this. Where are we?
It's like you get to multitask in there, huh?
Right.
That's awesome. Oh, it's better. I can see way better now.
This is open a breakout rooms. Please wait to be assigned. Let's see. Try this. See if you can see that.
Yeah.
All right, there you go.
Thank you.
Sure thing.
You look like you're pretty good on your computer if you can do that quickly. Okay. I'm impressed. Oh, it went away. Darn it. Is it going to be underneath my chat?
It should be in the chat, yeah.
It should be my chat, right?
Yeah.
Oh, there it is. Thank you. Okay. Okay. Please.
Yeah. So.
Okay. Okay.
Yep.
So. Okay. So what is new? All right. Oh.
All right. So what do you think?
So what I'm basing that off of, I'm going to say, it's confusing when you expression. Wouldn't it be the first? Would it be 0.5?
For some reason, I'm thinking 2.
2? You're taking, okay.
I don't know. We shall find out.
Well, no, and when you're reading it, that's when he says it can get confusing you. Sometimes he says to reread it a whole bunch. So just to make sure. Okay, I see that.
Mhm.
Okay, question 5. All terms below are like terms. All terms below are like terms.
Yeah, I'm gonna say true on that one.
True.
Yeah. I think
Question
so.
6. Simplify the following. Oh. I just wrote this one out. Okay. 2 times plus 5y. Okay. Simplify the following. Why can't I get you on here?
Doggone Chase says about the princess that I went back because there was that difference of amount. It says, here's what we did to research the dispute. Here's the resolution. We found no evidence of a billing error based on our research and the information available to us. The charges will remain on your account. So I got to go and say to Chase, you go back to Princess, or I guess maybe I have to go to Princess County, maybe.
Hey, Professor.
Maybe that's the next step.
Professor Clark. We
You're,
can totally hear you, man.
Oh, thank you.
Yeah.
I wasn't sure if that was towards us or not.
No, I don't think so. Okay. Where are you at with this one?
All right, so
Thank you for telling me.
Sure thing. Sure thing.
yeah. Okay, so hey Ryan, so
Yes.
Okay. I don't think mine came out correctly because
I combined the like terms and I got 3 okay. How am I gonna do this? How am I gonna show? So
well,
this,
yeah, no, go ahead.
I started by combining the like terms, right? So I had 3 start parenthesis 4x plus 6y in parenthesis minus 2 plus 2. And that's about as far as I got because
Simplify the following, which would equal out to well, I'm not seeing it on
so
2 times plus
let me see the answers here.
okay.
But
None of the above, so
I'm like a little stuck on this one because
yeah.
I don't know what to do with the 4x and the 6y
4x.
Because they don't.
They're not going. So
We got to get rid of something, I guess. I mean, I don't know.
and then wasn't that when he was saying to move it to the left? And
Yeah.
Yeah.
I don't know. You know what? I'm kind of stuck on this one.
Do we want to come back to it?
Yeah, let's come back. What else we got? All right. Number 7.
Well, this one was, that's the, oh. 7. Are you on 7, right? Because we're
Yeah,
gonna,
yeah. Let's just skip over that. Yeah.
all right. The word, multiplication, division, addition, subtraction. I feel like that's gonna be in that book that you have, where you
Mhm.
found the last one,
I'm just gonna look it up real quick.
right?
Yeah.
Oh, it's division,
Yep.
isn't it?
Yep.
Isn't it division,
Yeah.
right?
Yes, that's correct.
Okay.
That's what I got too.
Okay,
Cool.
good. All right. Woo! Okay.
Take what I
So,
can get. All right.
okay, type in just the number.
Yeah. Let's see.
So,
All right.
so this is another one of the very to the left, isn't it?
Yeah.
Left.
3. All right.
Okay. Type in just the-